Hey everybody, this is Ron from Sage Escape Room, and I'm going to show you how to make a video looper with a push button or a relay trigger using the Raspberry Pi Zero W. It's going to be cheap, it's going to be easy, and I think you're going to really like the outcome. So here's what you need. You're going to need a Raspberry Pi Zero W, a micro SD card, an Octocoupler, a 12-volt relay or whichever trigger you'd like to use, a bunch of wires, a breadboard, and of course some resistors. We'll go into how we're going to use these later. The first thing you're going to need is a clean glass bowl, but make sure there's no particulates. In this bowl, you're going to put your Raspberry Pi W with the SD card already installed. Throw in your breadboard. Next comes the relay, then the octocoupler, the wires, the resistors. Now throw that whole thing in the oven for 30 minutes at 350 Fahrenheit. After it comes out, you'll see you've got a fully formed video looper.
That's funny? Nope.
Okay, so that wasn't funny. Let me show you how to really do it. The first thing we need to do is image our Raspberry Pi. I'll put a link in the description so you can find the one I used. You need to use any type of imaging software you'd like. I use Balena Etcher. You will just flash that image file onto your SD card. The next thing you're going to need to do is enable the Wi-Fi communications on your Raspberry Pi. You have to create a blank file called SSH and a .conf file called WPA supplicant. In that file, you'll just paste some code to set up your Wi-Fi network. SSID is of course yours, and the password goes under PSK. Make sure you don't forget to put your country code in up top. US is for the USA. Just copy those files right over onto the Pi, and it's good to go. You'll be configured for Wi-Fi. I like to use Putty just to make sure that we can connect and log in and everything's good to go. Once you confirm that you can connect with Putty, go ahead and open up WinSCP so we can start moving the files we need over. You're going to want to move over the video looper program, which I'll share in the description, and you're going to want to move over your two video files in a folder called videos. Just make sure when you move them over that the right permissions are selected. If you just type in 777 into an octal field, it'll make sure that it's done correctly. All right, now we're going to go back over to Putty. We're going to find our video looper folder, and then once we get to the right directory, we're going to run the install command. So we're going to type sudo, S-U-D-O, for superuser do, and then we're going to put a space, sh for the file type, and then another space, install.sh. I'm going to spare you the ridiculously long install time, and we're going to just power through it and fast forward it. Okay, we're done. So after we've installed the video looper and everything is ready to go, now I'm going to walk you through some of the code. All right, so inside the video looper, we're going to go to the Adafruit video looper folder, down to the video looper.py. So this code is coded in Python. Much of this you can ignore. The things I want you to focus on here are the GPIO setups, where you can assign the GPIO pins to the different functions that you'd like. Again, if you want to get deeper into it, you can assign additional pins and additional functions. Just go ahead and move through the code, and you'll have to kind of digest that yourself. You've also got the setups here for pull up, pull down, and then some initializations around where the movie directories are and all that. The other thing I want to show you here is in this GPIO add event detect space. This is where you're going to set falling or rising. Something like a button or something that connects continuity is going to want to have that GPIO.falling. Anything that's going to have an active where you're going to be increasing voltage when the signal comes, you're going to want to put .rising. I'm going to walk you through the Raspberry Pi board really quickly. So I've got here the pin out for the Raspberry Pi Zero, and I've shown the particular pins we've defined in this program. So if you don't change it at all, this is where you're going to plug your wires in. And then I'm going to show you a quick picture now of what that looks like in the physical world. Now I'm going to walk you through how to connect up your relay. So for a 12 volt relay, obviously we can't connect that directly to the Raspberry Pi as it will fry the board. So we're going to need to protect the board, and the way that I've chose to do this is using an octocoupler. So the way those work, we have the one side of the octocoupler that's going to power an LED, and a phototransistor on the other side that's going to open or close depending on whether the LED is on or off. All of that's contained inside this little chip, so all you really need to know is you can buy these chips with 4 or 6 pins. I've used the 6-pin type, so pin 1 is going to get your 12 volt supply, obviously with the correct amount of resistance depending on the octocoupler that you have, and then on pin 2 you're going to have your ground or common. On the other side of the octocoupler, again completely isolated so that you can't possibly damage your Pi, you're going to have a setup that is called a pull-up resistor. So I don't want to try to explain this because frankly I don't quite exactly understand. I understand it from a logic perspective, but not from an electrical engineering perspective. So I don't want to try to explain something. If you're interested, please Google octocoupler and pull-up resistor, and you'll find it no problem. But for this particular example, what we want to do is we want to connect the pin 5 onto the 3.3 volt GPIO pin with a 10K resistor in between. And then we also want to connect that same pin through a 1K resistor to the GPIO input pin that we're using for this trigger. And then the other pin, the 4 pin, goes to the ground. Now, one thing to remember, this is not the common ground that you're using from your relay. This should go to a GPIO pin ground that's on the Raspberry Pi. So once you've connected this up, I'm going to show you again what this looks like on the breadboard in the physical world. Right in the center of your breadboard here is the octocoupler. So what we're going to do is go from that pin 1 with a few resistors, in this case 2 in series, to give us that 1.2K that I was targeting. And that's going to then connect into the 12 volt supply, and pin 2 is of course the ground pin. On the other side of the octocoupler, you can see here our 10K resistor, which is spanning across to our 3 volt input to the Raspberry Pi, and of course the ground for the Pi coming in there. We've got the 1K resistor coming from that same positive side pin, and that's going to the GPIO trigger. So let's now see it in action. Got a promotional video here looping, connected up, and I've connected this to a relay that's connected to some touch sensors. We're going to go ahead and trigger those touch sensors, which will trigger the relay after this video loops real quick. So there's the loop of the first video, and now I'm going to trigger that relay, and you can see it triggers the second video. I've attached a button to drive the video back from video 2 to video 1, so I'm going to go ahead and show you that button trigger. And there it is, resetting back to video 1. And that's it. So that's it. I hope you enjoyed the video. Please check us out on all of our social media. The links are below, and we'll see you next time.